Hi,
Well, hi, Sarah. How are you?
I'm good. How are you?
Doing well. Let's see. Awesome.
Did you get the question that I posted on that post of roles? Like I shared a comment.
Yes, I did. Yeah, I'm really grateful you
Yeah,
reached out with that question. Yeah, we'll cover that today.
yes, thank you. Looking forward.
Absolutely. We'll give it a couple more minutes here. I know we have some more people that are joining us. I see that someone dialed in. Hi, my name is Josh. I don't know who's dialing in, if I know you yet or not.
Hi, Josh. But
Sorry, I didn't quite catch your name. I cut out just a bit there.
yeah, hi, Josh. This is Fred.
Fred, nice to meet you. Thanks for being here. I appreciate it. How did you come to find out about the community?
I think clicking on the IT Squared website.
Okay, great, nice. Yeah, I think we have some feedback in the forums or people reaching out in the forums sometimes looking for additional resources. So, great. What do you do for work right now, Fred?
Actually, I'm looking for work. I'm not working right now.
Okay, great. Yeah, what sort of work have you done in the past? Hey, Jarrett, great to see you, man.
Hello.
Enzo before.
Okay, awesome. Well, good deal. Welcome here to the group. We're glad to have you. We'll give it a couple more minutes still for people to trickle in. While we're waiting, this is my first time presenting slides as I'm going through here, so I see that I might be able to annotate things. I just want to try something real quick. Whoa, that didn't work. Oh, maybe I'm supposed to do that here. Okay, we'll give it one more minute. Supriya, welcome. It's great to have you here.
Thank you.
As we are waiting, I have launched a poll for you guys. You're welcome to go ahead and take a look at that. More just questioning about your experience with the community within the school platform and meeting other people that are within these groups. We'd love some feedback, just because those of you who have been in these groups for a little while have seen change week to week. So your feedback helps us out a lot. Thank you. Okay, well, I will leave that poll open and we'll go through and do our introduction here. So my name is Josh. I've met a handful of you on this call here. I'll be instructor is an interesting term. I'll be more facilitating the group. We're all studying here together. I am ISC² certified. I have my CISSP. I also have my master's in cybersecurity information insurance. Currently, I work as a security compliance and risk analyst. So I work this industry. I'm also a teacher. I'm at a university as well. So I'm very passionate about the field, and I am here as an opportunity for me to help learn how to teach. So thank you in advance for your patience as I work through kinks. And my commitment to you is that I would love questions. I absolutely love questions, and I'm not going to know the answer to all your questions. So I'll be honest with you about that when we come up against it, and I'll have a list of notes off to the side. A lot of you are aware of my list. Ask questions, because I love to see the list grow. So, things off, I would love to hear from some of you about how studying has been going, if you've had any challenges. I know we have some people coming up on test dates here before too long. So I'd love to just kind of have this an open period and hear from some of you.
Quantitative analysis, kicking my ass.
Quantitative analysis. Yeah, I think I saw your post earlier, John. Tell us about that.
It's right. I can't remember formulas. I I don't understand the questions when they're answered. When I get them wrong and I read the answers, I don't understand them.
Awesome. Yeah.
No, not awesome. It's a pain in the ass. Not awesome. I mean, I read it, I understand it. I go to engage in a question, mine goes blank.
Yeah. Yeah. Does anyone have advice on that? Has anyone else come into challenges studying those types of things that like, they just require some brute force memorization sometimes? Or what have you guys found that's been helpful in those sort of topics? Key links have been common in dealing with like cryptography is something that gets brought up similarly.
Yeah, I'll say this on the formulas in the beginning. I thought they were difficult to memorize as well. But as you do more practice questions and you study more, they'll stick. They're not as difficult as they seem to memorize.
Okay.
But I will say this. I will say this though, based on the number of exam questions I'm taking, there's several different ways they can ask you different questions, and you're not quite sure when and where to use which formula for the particular question that's being asked. I will say that. So yeah, it could be a bit misleading sometimes.
Paul, thanks for jumping in with that. I appreciate that. John, I have that question written down, so I'll add it to my list, and we'll get to that topic at some point. So I'll make sure I tag in that because I saw your post in the platform too, so I'll reach out to you. Anita, welcome. I don't know that I've met you here. I think Elvie, I saw you maybe join. Guys, glad to have you here.
How are you? Thank you for having me.
Absolutely. We're just doing some introductions, getting to know people, especially if you have upcoming test dates or challenges or successes studying. So love to hear from a couple more of you.
I'm studying. I haven't scheduled my test yet because it's an expensive test, so I need the money first. I have to get the money first.
You have plenty of time to save up studying.
By the time I get the money, I should be ready to take the test. That's why I said, let me just go ahead and study. But I've been in security for a few years now, so I got it kind of like I'm familiar with the industry.
Yeah.
What
domains do you work most closely with?
Probably access control, more likely one access control, probably asset management, vulnerability scans. I'm big on that. I'm experiencing that. More on the risk side too. So
fantastic. Yeah, that's one of the things that is really common for most of us. Have really heavy experience in 1 to 2 domains, are pretty comfortable in most, and might need some refreshers and deep dives on a few topics. And there's always a couple out there that are a little bit more challenging, like software development or SDLC is that for me. So yeah. Who else has been having some successes or challenges in their studying lately?
Josh, I have a question about the exam. Is it true that we have to pass the individual domains as well? Like it's not the overall score that matters, but we have to clear each and every domain?
Say that one more time for me, question. And John, can I ask you, would you mind putting yourself on mute when you're not?
I'm going to go on mute too.
Yeah.
Thank you. I appreciate that. Sarah, would you mind saying your question one more time for me?
Yes. So I'm asking that, is it true that we have to clear, like pass the exam in every domain? Like it's not the overall score that matters, but we have to like make sure that we score 70% above for every domain. Is that true?
That is a good question. I'll tell you my understanding, but someone else jump in because I think they'll have other maybe some more information. My understanding is that if you're taking the adaptive version of the exam, which is the case, I think, for probably everyone on this call, there's a handful of languages where the adaptive version isn't available. But if you're taking that, I believe if you in the exam fail a domain and are still not at that 100 question mark or the 125 question mark, whatever it changed to, then I do think that's a fail. But I'm not 100% confident on that, Sarah. Does anyone have any further insight into that or can correct me?
I just recently heard that too, because I was watching some podcasts and they were talking about the CISSP exam and how you have to pass all domains. One domain you failed automatically. That's pretty much it in a nutshell.
That's helpful to know. So,
but I think if you don't get to at least, I think they said if you get to at least 100, then there's a good chance you probably passed or either really failed. So I don't know.
That's a really good question, Sarah.
Yeah.
I'm grateful you asked that because that's something that's worth clarifying.
Yeah. I'm under the impression that possibly some of the questions are not singular to a domain. Maybe there's like a structure that some questions are give points for one domain and the other, because I recently took it and I went all the way to 150 and failed. And
Oh, damn.
yeah,
Oh.
and I got below proficiency on 4 domains.
Okay.
Wow.
And
So that's
yeah,
helpful.
like not below, I'm sorry, below proficiency and then near proficiency and then one domain above proficiency. And I got to 150 and it's like, hey, you didn't meet the minimum 700. So
Gotcha. Okay. That's
Yeah.
helpful insight as well. So
Okay. So on a scale of 1 to 5, how would you rate the difficulty?
I thought I passed. I was so confident.
Oh shit. That's the
Mhm.
worst fail when you think you passed.
But yeah, but the thing is, like, I also, I could have just taken my time a little bit longer. I finished with about like an hour left,
Oh, okay.
so I probably should have just taken my time with it. I thought I was doing really well because I was, it got to a point where I was just getting some of these really long-winded questions, and those were the harder ones. And then occasionally I would get like a one-sentence question, with really simple answer choices, and and that would just change dramatically for like the next 10 after that. So I don't know. It was my first time, and I'm changing my approach on it. My friends told me just take your time.
Yeah, just take it. Did you buy the insurance? I think you had to pay extra for that, like extra $200 for the insurance or something like that. Or
No, I ended up getting a voucher through my employer. So
okay,
yeah. But
nice. Well done. Well, just for encouragement for some of you that are going into the exam, Albie mentioned he kind of had that confidence that he had passed the exam and failed. It was sort of opposite for me. I had no idea. The adaptive testing really threw me off, and I didn't have any degree of confidence afterwards. I don't remember offhand how many questions I got, but I'm sure I passed just by the skin of my teeth on there. So it's hard to tell. In the middle of the exam, don't let how you think you're doing skew your own performance. You just focus on the question that's in front of you. But yeah, awesome. That's some great insight. Anyone else have anything heavy on their minds they want to chat about?
I don't know. I think I would have felt some kind of way if they let me go all the way 150 questions and I didn't pass.
Yeah,
I agree.
Mm-hmm.
I agree.
Yeah.
But
Okay.
you looked at it from a technical perspective as opposed to like a manager perspective when you answer some of the questions, because that's probably like easy to do sometimes. Because when I take practice tests, sometimes I find myself thinking like a security analyst instead of like a manager.
Yeah, very common struggle. How was that for you, Ellie? What was your insight? I remember you maybe bringing that up a little bit last week.
So I believe that sort of like how I did with the PMP, it's like I needed to forget about personal knowledge and experience and just try to go from the book of knowledge.
Yeah.
Because literally the domains that I got below proficiency were the domains that I had the most experience in.
Oh man.
Yeah.
Fooled himself
So you
a
already
little.
know what that was. You already know you was thinking about how it's done your way, and they want it done the book way. So
Exactly. So I just have to get a refresher on what the CISSP book answer is, at least the book of knowledge,
yeah.
Yeah.
What study material did you utilize, if you don't mind me asking?
I used the Learn Z app. I read through the book, the official. So yeah, those were the research I did. And then we have access to O'Reilly. I forgot the name of this person, but lectures for certain sections that I feel like I needed on. That's about it. I'm changing my whole study approach. I'm taking a break from the material, but starting next week, I'm going back in there and just taking a different perspective than before, because obviously I didn't do something right.
Good for you. Good for you just adapting to it. It's tough to kind of get back on the horse, so to speak, sometimes after an exam. So nice job, Elby. Cool. Well, boy, I appreciate you guys bringing that up. It's helpful just because I haven't taken the exam for a while. So hearing your guys' fresh experiences studying and challenges with the exam is really helpful. So, all right. We are going to go through a couple of things here together. So first of all, we are not going to get to cryptographic attacks tonight. I started in on the authentication mechanisms and the amount or the volume of things I wanted to cover kind of exploded. It's the whole mile wide, inch deep concept. So if we have a topic that really integrates well with a lot of other topics or concepts, that's kind of my preference. So cryptographic attacks are coming. Sarah, who is on the call here, actually, she is a moderator within our community. She's been helping out quite a lot. And I believe she's going to be helping facilitate the group this coming Thursday, which again, just as a reminder, is still the normal evening time, this US based. Next week will be the new schedule. So I think Sarah was going to cover some cryptography concepts. She has some pretty advanced education on that. So we are going to address a question last week, and Elvie, this actually might have been one of your questions. Let me know if it is, but on the concept of media reuse and data destruction. And specifically, we're going to go into some data destruction techniques and how we decide what sort of destruction techniques get used based on the type of data that it was holding in the system. So we'll go into that a little bit. Elvie, remind me, was that something you brought up to me? I don't know why it's sticking in my mind. Okay.
No.
Okay, I don't remember who that is offhand. We're also going to talk about some network security, and we're going to get pretty detailed into identity and access management. And we'll go into a lot of the different protocols in there. So single sign-on and federated identity are two of the main broad encompassing concepts that we'll discuss, and we'll go into detail on quite a few of the protocols that support those. I am doubtful we are going to have time to go into Kerberos, so we'll see. If not, that's something I want to make sure that we cover to go through the ticketing and tokening system and that whole process there. But I'd like to have some visuals ready for us when we do that. And then we've got some practice questions that we'll go through as well. So if you would jump into the polls and answer that, I'm going to end the poll here in just a moment. I'm not sure if I actually have a slide for backups. No, that's okay. So we're going to discuss media reuse and data destruction. I'm going to pull up my notes in front of me here. All right. Yeah. Boy, this is a good question. I wish I could remember who asked it to me. So first of all, when I go on my computer and I hit delete on a file, doesn't really matter. I'm not getting specific into operating systems yet. If I hit delete on a file, who can kind of tell me behind the scenes what is actually happening to that data? Who wants to kind of take a stab at just a simple explanation? What happens when you hit delete on a file?
I don't think you're actually deleting it. You're just deleting the pointer to the memory locations so that when data gets written later, it'll overwrite the data. But the memory will all still be there.
Yeah, that's perfect, Jared. That's a great explanation. So depending on the file system that you're using, and a couple of file systems that we have NTFS, we have exFAT, we have FAT32. You've heard a lot of these names. We're not going to go into file systems. But like Jarrett pointed out, each file system has some sector, some partition that's responsible essentially for having kind of an inventory of what data is on that disk and where it's located. So when you're going to access a file on your computer, it's actually going to reference that partition. So like, what's an example here? Let me get to my notes on that. So for example, NTFS, New Technology File System, it has the MFT, the Master File Table. And that's basically what it references when you click on a file. It looks at the master file table and says, well, where in this whole disk or this disk array is that particular file or that set of data? So exactly like Jared was saying, regardless of what the file system is, there's some partition to help find where it is. So when you hit delete, all it's actually doing is deleting the reference to where that is. The data is actually completely intact on that file system, which is why data forensics is really easy in those systems or in those situations. If you have a hard drive where you just pretend it's all just files and you just Control-A, select all, delete the files. And all that data is still present. And with forensic techniques, you could go in there through all the bits and bytes and pull that data back completely. So the master file table, the file allocation table is what FAT refers to, file allocation table. those are where those data pointers are stored. So when we talk about that, the data that's left over, the term that you'll hear is data remnants. And it's a simple, it says what is left over, what is remaining, what artifacts are potentially still on that hard drive or that storage medium that could result in data being accessed that isn't supposed to. So let me pause there. Who has questions on that piece alone? Just what happens when you're deleting a file behind the scenes? Any call outs or comments on that process before we go into other destruction types? Okay, you'll have to speak up because I don't have my hand raiser thing in front of me, so you'll have to actually shout out if you have something to say. So what do we do instead? We can't just delete the pointer in that partition. What we need to do instead is actually delete the data. So the term you'll hear, and this is a specific term, so I'm sorry I don't have slides ready for this. I want to get better about having slides ready and some notes ready for you guys to reference as we're talking. But clearing is the term that we'll use, clearing. What that does, there's different types of clearing, but it's actually going and writing over the data that was present on that disk. So it has all the zeros and ones, the bits and bytes. Clearing actually goes and writes maybe all ones over the entire section of where that data is supposed to ride, or it'll write all zeros potentially. So we're actually writing over it. So forensic techniques could potentially still work, actually. Forensics is really amazing. We're not going into that aspect of things. But there's still remnants, again, data remnants, even after clearing sometimes. So who has a guess on what purging is compared to clearing? Purging. This is another specific data deletion term. So purging is where we actually are doing that clearing process, writing over the data. We just do it multiple times. So it becomes a lot harder for forensic techniques to actually work because it's starting to get jumbled what that previous data remnants could be. So purging is another, just a more substantive type of destruction method. Sometimes purging is also combined with other data destruction methods like physical destruction. So purging is like the ultimate of what you can do because you're not only overriding all of the data, but you're also potentially physically destroying the media. And destruction is a really common one, physical destruction. Who can throw out a couple of ways of, like a couple of methods for physical destruction? There's a lot of different ways to do it. Throw out a couple of examples. Incineration, yeah, absolutely. You got the burn barrel, absolutely. What are a couple others?
Shredding.
Shredding, absolutely. Yeah, give me one more.
Hitting it with a hammer.
Hitting it with a hammer, good old trusty. Exactly. You can also, people drill a drill bit through the middle or something like that. Lots of different methods for that. So let's take the case that you're in an organization.
I got sorry, Josh. Quick question for on that note of drilling it, because I've heard about that. Just real quick for you that have more experience, I'm just asking this. Once you drill it, is that making it non-functional? Because the disk is still there. You can still retrieve data from the rest of the disk.
Excellent point. That's an excellent point, Paul, because we are destroying it so the disk might not be reusable, but there are other data forensic techniques where if you're just drilling through it, technically, if let's just say my hand is a disk,
right?
We drill through one piece, we've only compromised an aspect, or we could maybe get data from these other sections. Yeah, so you're exactly right. That's an example of where we would want to do purging first. Clear out the data.
Oh, okay, got you.
No chance you could get it out. But yeah, great point on that.
Okay, so use more than one method, basically, than just to drill it.
Exactly.
Okay.
It's just like defense in depth, pretty much, on a physical level.
Yeah.
So let's take the case that you're working in an organization that has some pretty sensitive information, and you have a lot of it. Let's say paper sensitive information, kind of a pain. I think Jared pointed out you could have a burn barrel to destroy that type of information. You could have a shredder, potentially. They have different ratings for shredders for what types of just how shredded it actually gets, I guess. So when you are working with destruction of sensitive information, sometimes you can outsource that. You can actually, there are companies that are specialized and even certified in data destruction techniques. And oh yeah, I'm really bummed whoever asked this question isn't here, because I'm going to post a link in the chat here. And this link is to a NIST special publication that deals with data destruction techniques. So just a quick aside on NIST, so you guys have my same mindsets on this. It's a great place to get answers to your questions, authoritative answers. And bodies like ISC squared or ISC2 use NIST special publications to inform how they actually build out their curriculum and their material. So if you have a question on a term that's really giving you a lot of trouble, I would encourage you, even though it might put you to sleep, to actually look up the policy or the special publication, or where does ISC squared get their definition and their information. It could be really helpful because they might explain things in a little bit of a different way, or you might use them in your work too. So for the CISSP specifically, it's not like a great study resource, but it's a resource to go when you have a specific topic or concept you want to study. So that link is in the chat right now, and you're welcome to go look at that. But when we are looking at data destruction techniques, and if you decide you want to outsource data destruction, one of the things you'll get is called a certificate of destruction. This sounds overkill almost to some people of, I want to get it destroyed. Why do I need a certificate generated to tell me that it actually is destroyed? What do I care at that point? But it's so that we can have audit records of what actually happens in the data life cycle. So we're getting a little bit out of scope from data remnants, data destruction, but have the concept of the data life cycle in mind when you're considering this. Where does data come into your control? Then we're going to talk more about how we manage access to that information and in our deep dive today. And then the data deletion or retention, potentially, will be determined by your policies or things like that. So let me pause there. Any questions, comments, anything we want to chat about further on that? I'm going to put...
I have a question.
Yeah, go ahead.
Yeah, sorry. So if you're using the purging technique, does that mean that media cannot be reused?
Great question. So this is the question on media reuse. And the answer is it depends on the classification level of the data. So also in the chat, I am going to put some classification notes, confidentiality based. Where's my? Let me get, there's one more. Let me see. Okay, it's a little hard to read there, but confidentiality-based classification, so that's one scheme of classification that you can use for an organization. FIPS, Federal Information Processing Security. This is another standard, similar to like a NIST special publication. This is another authoritative definition of how we manage certain aspects of information security. So this lays out impact-based classification. Now we look at impact, and we also can look at likelihood. Those are two of the main things that we look at when we're assessing risk, and that leads to media reuse. If it's really low risk information, like I have a USB drive, technically every time I'm putting different data on it, I'm reusing that storage media. Now there's nothing sensitive on it, so I can reuse it, I can delete it. I don't really care if there's data remnants. But when we start going to, okay, this is internal only information. Well, now we need to implement a process where, all right, we need to make sure there's no data remnants on here if we're going to reuse it outside of that context of internal only. So for the most part, when it comes to media reuse, people opt not to reuse media unless it's just public, completely unsensitive information. Just because it's a lot of effort and there's more risk compared to just buying some new data or provisioning new data. So does that answer your question? I can't remember if it was Sarah. I'm not sure who asked that.
Yeah, but I think what I'm trying to find out is that with purging, since you're saying that we have to combine some logical and physical destruction technique for like removing the data remnants. So for physically destroying that data, is it necessary that only for like sensitive data that we need to destroy the media as well? But if it's
Yeah.
not as classified, then we can use some alternate technique like degaussing or some other that would allow us to reuse the media for storing some other like unclassified information.
You're exactly right, Sarah. Yeah, thank you for clarifying.
Okay, got it.
Yeah, that's exactly right. If you use storage media that has a higher classification level, some of them might just require destruction, physical destruction of the media. Like especially the US government, if you're dealing with top secret classified information, they're not going to let you reuse anything. Put it in the burn barrel, degauss it, burn barrel it, and be done with it. So there's some things like that to keep in mind. But Sarah's right. If there is a lower risk level associated with the data that's already stored on that, makes it a lot easier to repurpose that and put it into reuse. So great. I don't think there was anything else that we're going to go into on data here. But I'll pause one more time in case you guys have more questions before we go on into authentication mechanisms.
Hey, I got one question.
Yeah,
I mean, you can continue on, but if you have like a couple minutes at the end, I have an exam question that I want to pose to you because I still don't understand it, and it's related to this topic.
Yeah, and this is like a practice question.
Yes, sir.
Absolutely. Do you want to do it right now?
Yeah, sure. I didn't. Okay, yeah, let me just post it real quick.
Yeah. If you want to grab that, Paul, then we can do it. Let's do a practice question together. That's great. Thank you. If you guys ever run into practice questions where you are not confident, bring them up. Yeah.
Because I need this explained to me.
I don't know if you can copy and paste the text in the chat, or I don't know if you can share your screen. I'm not sure if there's permission.
I just posted it. Can you guys see it? Or
yeah, there we go. Okay. Here, how about I just make us a poll real quick for this? So
sure.
Let's, before anyone actually answers, let's.
All right, guys. No cheating.
No cheating. Exactly. No cheating. Okay, let me get a poll ready for us. Awesome. It'll take me just a quick second here. Oh, that doesn't work, actually. Okay. Sorry, that did not save like I thought it would. Let me try one more time. Almost there. Thanks for your patience, guys. I'm still kind of learning how to manage these platforms. Oh boy. And okay, so I'm going to launch a poll here, and then I'm going to make you walk us through this, Paul. I want you to just walk me through kind of what's sure. Bothering you about it. Which of the following data sanitization methods is most likely to prevent data remnants on an SSD? Ooh, SSD brings an interesting point up. There's a reason this is confusing already. Okay, awesome. And we got a split vote. Perfect. Keep going for a minute, gang. We got 20 of us on this call, so there should be a couple more people who can vote. All right. Now, let's pause for a moment. What are the key distinctions between an SSD and other types of storage media that we would care about?
Well, it's not affected by degaussing.
Not affected by degaussing. Why?
Because the way it stores data.
It's an electronic storage media.
Yeah, exactly. So that it uses actually, it has electronic circuitry in it that is not magnetized in the same way that like hard disk drives are. So degaussing does nothing to an SSD in the sense of data destruction. So that's an important thing to know. SSDs, degaussing doesn't work. We have to find another way to do that. So we crossed one off our list. It's not going to be degaussing. So we have overriding, we have purging, and we have encryption. Now let's pause and let's focus on purging and overriding, those two concepts, because we discussed purging. I use that word. Refresh my memory, someone, on what purging is, and use the term clearing in there as well. I want to hear clearing and purging.
You said that, or at least what I interpreted was purging was clearing being run over and over and over. So writing zeros over and over and over. And it can also be a combination of other things, but it's mostly a focus on clearing a multitude of times.
Perfect, Jared. Well done. Yeah. So clearing, we're going over that data and we're overriding it with zeros and ones. So first of all, let me pause. Is overriding correct? Is it going to prevent data remnants on a solid state drive? Yes or no?
No.
So it's a trick question here. It is no. You're accurate. It's because there still could be remnants. The key word here is the most likely to prevent it. So overriding and clearing are going to be synonymous in this question. So when we're talking about overriding that data, we're going to go and write zeros and or ones over the top of that. Purging, as Jarrett reminded us, is that same overriding process, but done multiple times and potentially has physical destruction or something else linked to it as well. So, all right, so we've kind of unpacked that purging encompasses overriding, so it's above and beyond, and degaussing isn't really relevant. Who wants to take a stab at why encryption should or should not be our option here?
Well, wait.
Because it could be unencrypted.
Can be unencrypted. Yep,
Yeah.
that's a decent answer. Donita, did you have something else to add?
It doesn't prevent data remnants. It only provides confidentiality.
There you go. Yeah, it doesn't remove the data remnants. This is one of these things that you've really got to pay attention to the way they're phrasing the question. And that was perfect. What is the most likely to prevent data remnants? Not access or to enforce confidentiality. There are ways that encryption could help us potentially in these processes, especially if we're maybe working with cloud service providers where we don't have physical access to that storage media. We might encrypt it, and then we might override it, and then encrypt it and override it. What might that be called? What's another term for what I just described?
Can you mention that again? I didn't get the whole.
Yeah. What happens if I'm taking a piece of storage media, just a hard drive or something like that, and I encrypt the whole thing? Maybe I toss away the encryption key, and then I go and overwrite the data. Maybe I encrypt it again, and I double encrypt it, and then throw away the key, and then overwrite it. There's a term.
I think that's digital shredding, I think.
No, it's some kind of erasure. I think it's
Crypto shredding.
I think a cryptographic erasure or something like that.
All right, you guys are on the right track. You're overthinking it. Pick an answer from our poll. What is that? What could that be?
Purging.
Oh, I'm gonna go.
Degaussing.
Yeah, we can use all sorts of methods in purging. We definitely need to override it at least once or a couple more than once, but there can be other methods that are included in purging. So purging encapsulates quite a lot. Encryption here, though, Danita nailed it perfectly. We want to get rid of the data remnants. Okay, awesome. I'm going to end that poll. Great job, guys. You did fantastic on that. Paul, thanks for bringing that up. Crypto shredding. Yeah, there might be some other nuances to that, Basma, in regards to crypto shredding. I don't have anything specific prepared on that. I can't give you a distinct answer for what that would be versus some of these others, but I think we're on the right track for that. Does anyone else have more specific response to the concept of crypto shredding?
Josh, what is the answer for this question?
It pretty much.
Well, I guess Paul, do you have the answer? Because my answer.
Yeah. Okay. Yeah. So I was waiting for us to hash it through. So I'm going to post the answer now. And my answer initially was C, purging. but based on the exam thing, drum roll please.
It's encryption.
The answer is D, encryption.
Really?
Yeah.
Okay. So that's a question where we've all kind of come to a conclusion where we disagree and think it's purging. It's possible.
Can I give my reason since I
No, I
think
think
Please do, Sarah. I'd love to hear from you, Sarah.
Yeah, okay. So I read the question as that which method will most likely prevent data remnants. So remnants is basically the leftover data, and we do not want anybody to delete that. So if it's encrypted, then that would probably provide us the most protection. I don't know. That's how I interpreted the question.
Yeah, and I think that must be the interpretation they're looking for on there. I think that might be the case. You could argue both ways, truthfully.
Even if the data is left there, that they can't get to it because it's scrambled, so it's encrypted. So that would be the
Well, yeah, I was thinking along those lines as well, but everything that's encrypted has a key. If someone gets a hold of the key, it can still be, decrypted, right? But
the likelihood of getting a key.
No, but if there are gaps in the data, then I think even the decryption wouldn't be that easy.
Well, no, it won't be easy, but the data is still there.
It'll be there, but it'll be scrambled. They won't be able to decrypt it without the key. They would still need the key because I think what the erasure does is it encrypts the entire it involves encrypting the entire SSD.
Yeah, I'm glad you brought this question up, Paul, because this is representative of what happens on any CISSP test question. There's two answers that make a lot of sense, and depending on which perspective you look at it, you could get two different answers. Sarah's justification is totally reasonable, as is Danita's. So purging and encryption, I think, would both be good answers depending on your perspective. And it's hard to say.
If I could add to that, Josh, the other key word there was sanitation method. And I think by definition, it's just the goal of sanitation is to make the data unrecoverable. That could be it. So I mean, we might get strung up on data remnants, right? But then they're asking for sanitation.
That's
right. But let me just say this real quick while I pose the question. So the key words that stood out, well, one of the key terms that stood out to me was when it said which of the following data sanitization methods. I don't see encryption as a data sanitization method. I mean, I could be wrong there.
Crypto shredding is part of
okay, so no, it is. So I was actually going through that book, like the official study guide, and one of the methods is actually if we do not have any other methods. For example, if we have our data stored on the cloud, in that case, we cannot do like any of these. And for that, the best method would actually be encrypting the data and just throwing away the key or destroying the key. So it is one of the sanitization methods.
Yeah,
right. But is that a data sanitization method, though? I'm not saying it's not a good process. I'm saying is encryption a data sanitization method?
I'm going to look up
used for that.
Just think if you have a laptop that gets stolen and you have an encryption mechanism on the laptop, and then the one way to get rid of the data, make sure the bad guy doesn't get to it, is you erase all the data on it, making it unavailable to the bad guy who has the laptop. So I can see where encryption would be the right answer if you think in terms of hard disk encryption.
Yeah, I'm not saying it's a bad answer. I'm saying is encryption a data sanitization method? Because that's what the question is asking. Which of the following data sanitization methods? Right.
I'll look up the official answer for us, Paul. That's a good question. Let me just peek in my glossary and see if sanitization comes up, and it might have if it doesn't have a quick answer for us, I'll just get it for us later.
The NIST guidance you actually just shared in the chat talks about it. So 36, if you would see them, it talks about cryptographic erase.
Fantastic. Look at that. We have a pro in the conversation. And I'm sorry, I don't know that you and I have met. Could you let me know your name?
I am new. My name is Sandra. I know it shows up as is and is. That's just the email address.
Perfect. Well, Sandra, thanks for being here. Thanks for actually taking a look at that. I appreciate it. So for now, I have that question jotted down. and I'll have an answer for us next week that hopefully will help explain it. Because obviously I have a misconception about that somewhere too, because I feel pretty strongly it's purging, but then encryption, obviously there's some gaps in my knowledge for how we could use this for data sanitization. So take a look through that NIST special publication if you guys want, but I'll have an answer for us next week.
All right, thanks a lot, guys. I appreciate the feedback and the discussion on it.
Fantastic, Paul. I love that. You can bring a practice question every week if you want.
It was a good question.
Yeah, I love the splits on there too. That's really great. Okay, so let's move on to network address translation here. All right, so there's a couple quick concepts, very basic, that we'll review. First, IP address classes. Who wants to unpack why do we have IP address classes? What is the point of that? Just keep it in simple terminology. Most of us are probably pretty familiar with these concepts here.
So it's because we kind of started to run out of IP addresses, and so we created this NAT system where there will be one public-facing IP, but then internally inside the network, we have IP ranges set to the size of the network we need.
Bingo. That's perfect. Yep, exactly right. The IPv4 network range that we have that exists, too small for all our devices. What actually is coming about that will help address that problem of limited address space? IPv6. Awesome. Thanks, Basma. Yep, we'll see IPv4 in most scenarios as it's still kind of mapped and linked that way. IPv4 is still pretty much the standard, but good to be aware of that change is coming. At some point in our careers, we'll get to work more and more with IPv6. So that leads to public and private addresses. Public addresses. This is published on the internet. Everyone has access to these in the sense that it's used for actual online communications. And it maps to a specific endpoint, one endpoint or one network potentially, as this is leading into. So we'll use the illustration of SOHO, small office, home office, because it's a pretty simple network architecture that we'll work with. So a SOHO, typically you're going to be landing in a class C or potentially a class A range. It doesn't particularly matter in a SOHO. It doesn't matter what range you're actually using for these types of networks. They're more nomenclature or best practice use. So if I have my small office, home office network, chances are I have one public IP address that my internet service provider gives to me. Is that static or dynamic? Who wants to take a guess of whether my home public IP address would be static or dynamic? What is a dynamic IP address in this context? Maybe we can start there.
I think it would be dynamic.
Would be like, having a number of IPs in the pool will be rotated.
Yeah, exactly. So in a dynamic IP address scenario, there is a pool of IP addresses that isn't necessarily assigned at any given moment. They're dynamically assigned when hosts request, when they need an IP address on a network. So when my laptop connects to my home network, it reaches out and goes through that period where it's joining the network and it gets assigned, through DHCP, bingo. Absolutely, there's these different protocols behind the scenes that are going on that my workstation now is assigned a private IP address. So a private IP address, the internet doesn't see it. My home computer can't just jump directly to the internet. It has to go through some intermediary point. And that is most common for network address translation on a firewall or a router. So what happens in simple terms, if you are reaching out from my laptop and I want to go talk to Google.com. So I have a private IP address, it's my laptop. Google has no way to reach to my laptop and start direct communication. It has to go through my firewall or router. For me, it sits on the same box. In an enterprise, they might be separate boxes, and network address translation would take place on the device depending on the type of needs of the organization. So it would kind of depend on the architecture of the organization, how they have things designed from an architectural point of view. It also could be a performance thing where some devices are specialized for certain processes, like network address translation. So when my computer reaches out to Google, it goes and has its private, its private IP address. When it hits my router, there's a translation table on the router that holds my IP address, my private IP address, and replaces it with its public, my router's public IP address that it has, that's actually internet facing. That any system in the world can use my public IP address to ping my firewall or my router. So the whole internet knows how to access that. So when I reach out and do communications, that source IP address is changed. And the true source IP address, my laptop, is stored on the router or the firewall in that table. I can't remember the specific name of the table. Does anyone remember it offhand? It is something just like IP translation table or something like that. Does anyone know it offhand?
Is it just a routing table?
Could just be just a routing table. I think there's a second piece of that that is included in the routing table with a specific name, but you're right. It is essentially, it's just a routing table. That's essentially what it is. So network address translation. We've talked about the dynamic aspect of it. I have my home office and I have one public IP. Behind that public IP, I can have a whole range of my private IPs that I can communicate to. So let's take this a little bit of a step further and let's start talking about how network address translation works, not just in dynamic, but in some of the more technical applications for enterprises, especially as how you would use it with a VPN. So what are the problems? Let's just pause and take a step back. We're using network address translation, so our private IPs and public IPs are being translated on our firewall or our router. Now let's take the scenario that I am a remote office worker and I want to use a VPN to connect to my employer's actual network, their on-premise network, so I can access files or data. So I'm using a VPN to connect with them. How does network address translation work with VPN? Because whose IP address am I using during that? Who wants to just kind of bring up some thoughts on what are the challenges that we might face with that? And then you can use some of those terms that are on the slide if you want to, but unpack that for us a little bit. NAT traversal is the concept we're looking at. And first of all, NAT traversal is not a universal capability. The router or the firewall has to actually be aware of the VPN traffic. It has to be aware of that level because there's encapsulation that is actually taking place with this. Encapsulation is how we avoid the issues that come up with this. So when your private IP address is reaching out and starting to go through that translation into a public IP address, it actually gets encapsulated in the VPN setup. And that's why the dynamic versus static setup can be a little bit tricky here. Because if their dynamic IP address is being used, the configuration is changing periodically because we don't know where we're communicating to. We discussed IPsec last week and the benefits of using that with static IP addresses, because you can have point-to-point tunneled communication that's really set up, or you can have site-to-site, but have a static VPN server or an equivalent where we're all reaching out to. It makes configuration a lot easier. So network address translation, you guys summed it up great. It's a way to have public and private IP ranges communicate to each other. So anyone have questions on network address translation before we take this a little bit further into authentication?
I don't understand the difference between NAT traversal and dynamic NAT.
Yeah, so dynamic NAT and NAT traversal are a little bit different concepts. So static NAT versus dynamic NAT. When I join a network with my laptop, it's set up in most small office, home office architectures where it's dynamic. You're allocated an IP address from that pool dynamically. Just it's randomly generated essentially of what that IP address is, just something that is available in that range. And I think I saw someone in the chat maybe talk about DHCP pools or DNS. I'm not going to talk about DNS, but DHCP is kind of in that similar range of how hosts are allocated and protocoled together. So dynamic NAT, your IP address that's linked between your private and your actual public is going to be random. In static, you're going to have a assigned private IP address that is static, almost like a route table. Again, I think maybe that was Susanna that brought that up. It's a route table, essentially, when it's static. So you have a static private IP address that's mapped to your public IP address. So that relationship is a one-to-one. Versus dynamic, your private IP address just rotates internally. And then the NAT traversal, where we talk about the static versus dynamic there, that refers to the external IP. So my external IP is dynamic. If I want to VPN into my home network, I need to know the IP address, or I need to use something like dynamic DNS as a workaround of that, but I have to know where I'm going. So a static IP address or static NAT, the static endpoints there, makes that a lot easier to configure, especially when we're dealing with tunnels. So I hope that answered your question there, Sarah. I know it was a bit long-winded.
Oh, yeah, got it. Thank you.
Yeah, and Cliff mentioned, yeah, dynamic, unless you pay for a static IP addresses do cost money because you're taking an ownership and a bit of responsibility for that IP point, that asset. So, okay.
Hey, Josh.
Yeah.
Can you go through that NAT traversal again? You completely lost me. What external is dynamic? Wouldn't the internal IP be dynamic? I don't get it.
Great question. Great question. I appreciate you asking. So let me pull up my notes and let's see what we have that's a bit deeper we can go into on that. Okay. So static and dynamic NAT. There's a distinction that's important for us here, and that's, are we talking static internally or are we talking static externally? And I'm going to attempt to do a diagram for us on the fly a little bit here. I'm going to try and share a different screen with you. And we'll try and jot this up together. Okay, so network address translation. We have a start point, and let's just have this be like a laptop or something like that. We'll just call it an endpoint. That endpoint is reaching out, and let's say we are trying to access some information. Well, let's take it both ways because it's going to take it both ways. So we have a packet that comes to our router or firewall. If it is a packet that is internal to our network, in other words, there's already a route table for it, then it's just going to be passed along internally using routing. Otherwise, it's going to have that IP address swapped out on there. So we have two places where this shows up. We have static and dynamic endpoints, and I guess actually it's technically three, because we also have what is the resource we might be accessing potentially too. So there's three endpoints that we need to consider. So you have your private IP range, and you through DHCP could have a pool of IP addresses that get assigned dynamically. So internally, private IP addresses, we have dynamic and then we have static. So like my printer, I use a static address so that I always know where my printer is. So that's the internal piece. And let's take that here as our internal network. Static versus dynamic. We have IP pools that are assigned through DHCP. So let me just pause there. Does that element of dynamic versus static make sense? I know that's kind of the easier part, but I want to make sure that's clear before we go on to the other parts.
No.
Okay, perfect. Let's go through that a little bit more. So we are going to do, what am I going to do a circle here. All right. So well, that's not a circle. What is that? Endpoint. And let's say this is a internal endpoint. No. And we have our internet. Let's put an external resource. And let's do one more internal, but let's make it a server instead. Okay, so static and dynamic. Let's go through these concepts as they show up in each of these, because it's important to make sure that these are clear. They're important concepts for us. So we have a pool of addressable IPs. We have a range of IP addresses that can be done. So if I have a home network, 192.168.0.1/24. First of all, /24, what kind of notation is that?
CIDR.
CIDR notation. I don't actually remember what CIDR stands for offhand. Does anyone know that acronym offhand? I do not remember it. That's okay. That's not the point of this. So we have a private network range that we're going to use. So then we're going to have a dynamic pool. And then we're going to have static assignments is the word we'll use here. So we're going to look at our internal network first, our internal network. So there's usually in enterprise environments, there's a combination of both of these approaches at play for internal assets. So there are endpoints like servers or printers that you pretty much always want to know where they are. And when you're configuring their communication and security protocols and authentication protocols, you want to be able to point to a specific IP address and have that be the same IP address every time. So that if our identity and access management server, our Active Directory server, through some update, it reboots, it doesn't get assigned a random IP address. We need to know where it is all the time. So that's the static piece of this. So this internal server, let's give it a static IP address. Let's just say static IP address. So this server, no matter what happens, every time it is on the network, the router where it's actually assigning out the DHCP is going to recognize, hey, this is the device that's trying to join my network. I know that device always gets this IP address. So that's what's happening with the DHCP piece. And then there also behind the scenes is the route table as well. So routes can be static or dynamic. That's a little bit less of what we're talking about, but I want to make sure that's clear. Endpoints and IP assignments can be static or dynamic, and the routes are going to be static or dynamic. Both of those are going to be at play here. So an internal endpoint, we might have instead, we might want to say, let's just, if it's for laptops, we're just going to do dynamic. We don't need to know who is there. And we're going to use what are called lease times to reassign IPs. That way, our network range or available IP addresses aren't getting chewed up and used. So let's go through that just a little bit more detail. First one, while I'm taking notes, is this making a little bit more sense? Who has additional comments or questions?
It's helping. Thank you.
Cool. Awesome. So pretend with me that this is going to be our pool. We're going to pick out 21 IP addresses or 20 IP addresses that we want to be as a part of a dynamic pool. Well, if you're on Windows Server, you can set this up using DHCP, so you have a pool, and you can even label it. I want to know that any workstation that goes, any device that's in this specific group is going to be assigned into that pool of available IP addresses. Their IP address, their private IP, is going to get assigned from that pool. So that's how that's allocated within DHCP. So this internal endpoint, the first time it joins, this might be its IP address. But if it joins a couple of days later, this might be its IP address. It makes no difference, really, because the routing tables and everything in the back end is going to update. And yeah, perfect. We're going to go into NAT traversal in just a moment. We're going to build up to that here. First of all, oh my goodness. Those of you who have been studying with me for a little while know this happens every single week. We are already 4 minutes over time. Part of our schedule change next week is going to an 1.5-hour sessions, so that we have time for practice questions and me getting off track on some different things that I get distracted. I love going through these things. So I want to apologize for going 5 minutes over the time that we had scheduled, and I'll be continuing on for the next 25 minutes. So if you need to jump off, I really appreciate you being here and your patience on going over time. But if you're around, stick around with us. So dynamic IP addresses. Every time this endpoint joins, it's going to be allocated something from the pool. And then when it's lease time, and this is something that would be configured on the router of how long this is. And it's usually expressed in, I think, minutes maybe or something like that. But we'll just pretend it's like 12 hours. This might be something a coffee shop might want, because let's pretend they have 256 available IP. And that's actually not true, because if this is their network range here, how many addressable IP? Oh, Cliff, you spoiled it. 254. You're exactly right. 254 addressable IPs. What are the other two? Does anyone know offhand the other two IP addresses that aren't addressable?
Network broadcast.
Network ID and broadcast ID. Perfect. Yep. First and last of the network range. So, or the 0, I guess, on that is what that is. So, we have a relatively small number of IPs available here. The reason dynamic is so helpful is because take the situation of a coffee shop. We have high traffic. A lot of people are coming in and they're connecting to the Wi-Fi. They're there for a few hours and then they leave. Well, the router has still assigned out that IP address. It's not available in the pool. So at some point, if our lease time is too long, those IP addresses are going to run out and there's not going to be any availability. That leads to some issues. So your lease time is important when considering this. Yeah, and Clef just jumped in that the available IP range is going to be different. Like for WAC 24, it'll be something versus WAC 25. So yeah, thanks for bringing that up. The 254 available IP addresses is only applicable in a WAC 24 subnet. So yeah, great call out, Cliff. Thanks for bringing that up. It's easy to make a mistake if you're not comfortable or work with subnetting very often. Okay, so this is the internal side of things, how dynamic and such are working in play. So we have an endpoint that is missing in this diagram. We need our NAT device. And we'll have this be a combo router firewall to keep things simple. Now the external resource, and this, which is also sort of an external resource, this is the bridge between our private IPs and our public IP. So let's grab a public IP for us. Who can tell me what IP that is?
That's Google.
Google. Bingo. Good one for testing and such. So we'll pretend we're Google here. Now, we've talked a little bit about the static versus dynamic here. And pricing and size of the organization are two of the major things. We've discussed this mostly already. Just a quick recap. For most homes, small offices, dynamic is fine because it's flexible, it's free. I mean, free included with your ISP. Static makes configuration much easier for like enterprises. And we'll work in that traversal, we'll see why. And yeah, it's more user friendly, I guess, from a configuration standpoint. So we'll take the scenario that this is static. Dynamic is possible. It's very reasonable depending on the size, but just know that internally and externally, static and dynamic are at play. This endpoint, static and dynamic are also at play. Again, remember this also has an internal IP address that is also going to be static. It's very likely we would want our firewall and router. We want to know the IP address is the same private address every single time. So this will have actually two static IP addresses on in this scenario. The internet communicates through this same concept, really. It's the exact same concept, except instead of this type of a range, it's using a public range. So we have that list of the different types of IP ranges that were in front of us, and there's the publicly available or publicly assignable. So there's a public range that's dynamic. This is what any of our homes would have, is a dynamically assigned public IP address, versus static is what we're looking at right here. This would be assigned by your ISP, a static IP address. So let me get rid of that. Okay. External resources, I have a couple of things that we ought to know about that are going to be related. First, dynamic DNS, and then we'll use static IPs as well here. Okay, so if I want to reach out to, we're going to use google.com as the example. 8.8.8.8. That's a static IP address. It doesn't change. It's not ever going to get assigned to anyone except Google. So a year from now, 8.8.8.8 will still refer to Google. It has a static IP address. A lot of Google's resources are going to use static IP addresses, especially given its size, but it's common in organizations. Say you have a server that you want to host like an application on. Well, using a static IP address is going to enable us to do some different configuration items on this. So let's take the case that this is like, let's say it's a company knowledge base, and we want to assign it. So a static IP address is really helpful because it's external. Maybe we're hosting it in a co-location, a colo, or maybe we're hosting it in the cloud. So it's internal to our network, depending on how our architecture is, but it's external in a sense too. Dynamic DNS. This is helpful when we have dynamic IPs that we're working with. Who wants to take a stab at the relationship between dynamic DNS and how that helps us work around issues with dynamic IPs on the internet? Anyone want to take a stab at that?
How would that be helpful? You would have static that's chasing a dynamic address.
Yeah, great question. Great question. So the place where dynamic comes in, you're correct. It isn't necessarily related to a static IP address. We would use dynamic DNS mostly with dynamic IP addresses. You're absolutely right. And the reason is DNS. It links these concepts together. So DNS can be linked to an IP that's dynamic. There's some configuration that happens behind the scenes on this. All I want you to really be aware of right now is that if you're using a dynamic IP address, you can use dynamic DNS so that people can still find your resources. So if I go out and start a website, helpfulcissp.com, and I'm hosting this on a server that has a dynamic IP address. Well, I have a domain name though that is not dynamic. I bought that. I am hosting it somewhere that is using a dynamic IP, so that's not static, but at least this is. Dynamic DNS is what helps translate those two. So if you have a web resource using DNS that's published online, then the dynamic IP address can be linked to it by using dynamic DNS. So I'm going to pause there because that's a lot of dynamics and statics, and we're starting to talk about DNS here. So I just want to pause. Who has some questions or wants me to maybe go a little bit deeper, clarify some concepts on here before we start bringing in NAT traversal in?
Never mind. I'm. You lost me on. What is the relationship between the static IP or dynamic IP and dynamic DNS? I'm sorry, Josh. I really don't. I guess I haven't.
No problem. I appreciate you just being honest on that, John. And if I'm not able to answer your questions in this session, then feel free to reach out to me on the school platform because I want to make sure that these are clear for you. So what would be a good way for us to take a look at that? I wonder if I can. Tell me a little bit more about what are there specific concepts or applications that maybe aren't quite clear here? And if you want, we can just kind of keep moving forward and you and I can chat offline.
Keep moving forward. I don't want to take up everybody's time, but
okay, sounds good. Anyone else have questions or things they want to touch on this before we jump into NAT traversal a little bit more?
I didn't have a question, but I was a little bit confused. But I kind of get the understanding about what the dynamic domain name service is supposed to do. I think it basically just makes sure that the name doesn't change. Because I guess it often changes because it's dynamic, so it's always changing. So to make sure that it stays consistent, I think that's what the dynamic domain name service is supposed to do. Am I on the right track?
You're on the right track. You're on the right track. This is my fault, you guys, because when I
no, it wasn't your fault because I actually got your. I understand the way you explain it. I just had to get it because I didn't know what dynamic. I knew what DNS was. I didn't understand why it was so dynamic, but now I get why it's dynamic. But the explanation was made it. The understanding of what the dynamic was made your explanation understandable. If that makes sense.
I hope, yeah, I think so. I hope so. I don't know if this will clarify things. If we have any type of an asset that is using a dynamic IP, meaning it gets rotated through that available pool kind of randomly, there's not static routes, it's all dynamic. So every time it connects, it's relearning and getting repositioned in the network. If we associate that using the domain name service with a domain name, so like hosting a website or an application is the perfect example for this. If I have a website, I'm hosting that website somewhere, it's on a server. That server, if it's using a dynamic IP address, I can't access the domain name and have it linked to a static IP address because it doesn't exist. So dynamic DNS is what does that translation for us. So when I go to 8.8.8.8, it takes me to the same place every time. If I go to google.com, then it starts to use dynamic DNS where any of the endpoints that are required for that can be mapped to that. So we're going to not go any deeper into that here because we're running up on time. But these are great questions, and I appreciate your guys' willingness to just engage too. Of even if it's something is not making sense, continuing to ask questions, continuing to allow yourself to be frustrated is really helpful. Because one of the philosophies I have is the obstacle is the way. If there is something that's an obstacle to the goal that you have, the only way you're going to get through it is to get through it. So if there's a question you have, I'd encourage you to lean into it. Okay. We are going to go through traversal. Let me grab my notes here. Okay. Let's clean this up a little bit. We'll keep the same kind of configuration here for the most part. Oh, I stopped sharing my screen with you. Sorry. Okay. So traversal. Traversal comes into play when we are using VPNs in this context. So VPN, what happens to your IP address when you join a virtual private network? Someone tell me what happens to your IP address.
Hidden?
Hidden is,
think
hidden is an aspect of it. Absolutely. There's a couple different aspects that'll happen. So there is a sense of anonymity because your private IP address is getting reassigned actually within the network you're joining. That virtual network, you now get a new private IP address because you just joined a new network. So there can be static and dynamic in play there. VPN networks can absolutely have static assignments if necessary. So we have our network. So the other concept that we need to talk about is encapsulation. Not specific to VPNs, you don't need to go into any detail. Who can tell me what encapsulation means when we're talking about packets, IP packets? What is encapsulation in general terms?
Well, basically going up and down the TCP/IP, I mean the stack, kind of like an onion. You're adding different layers.
Yeah.
Up and down the stack.
Yeah, that can absolutely be how it is. So when we're encapsulating it, like Paul is saying, we're going to add a layer on either side of that. So we're going to take our packet and we're going to encapsulate it. We're going to wrap it is almost another term you could use for it. So we're going to encapsulate that packet when we're talking about, I guess I should actually put the term up here that we're learning about. NAT traversal, or NAT is the way you'll see it there. So what is the problem with this? Why do we even need this? Well, because let's take the scenario instead of an external user. We're now an external user, let's say a remote user. A remote user. I'm a remote worker. I have to connect to my employer's network somewhere else. So I have to follow a similar process to this. I don't actually know if they use NAT traversal. I guess we'll unpack this and maybe it'll make sense. So we are going to reach out over the internet and we're going to set up a VPN connection here. Something that would look good for a VPN. So you called out a couple of things that are happening when we create this VPN tunnel. Oops. That didn't work. So the remote user is going to reach out and we're going to set up this VPN tunnel. Network address translation. We're going to walk through this slowly. The remote user, we're going to set up in a VPN tunnel. This remote user is now sort of inside of this network. Sort of inside of this network. Who can tell me why that is? Since we're on a VPN connection, when I say that we're sort of inside the network, what are a couple of the protocols that we've been talking about that are now happening from this network and not our old network, like my home network? What are a couple of things happening?
Because the remote user is authenticated and assigned the same IP address as the internal network, like from the same range.
Authentication is I'm glad you brought that up, Sarah, because unfortunately we're not going to have time to get in some of the authentication pieces of this that are a little bit more detailed, like radius or TACACs and how these play into some of these. But yes, when I join a virtual private network, the DHCP server, which in this context, let's just take the case that it's that router firewall on the same device, their DHCP server is now going to assign me an address. So my IP address could be static, could be dynamic. We haven't defined that yet. It could be either way, depending on the organization. But I now have an IP address that's internal to this organization. So again, let's use the term physical and logical. Physically, my person is sitting externally. I'm not inside their physical network. I'm plugged into their jack or connecting to their Wi-Fi network. But logically, it looks exactly like I'm sitting inside of this network. So I have the same private IP address. I'm using the same private range. I'm using their routing tables from this. I'm effectively sitting inside their network. There are other aspects where my home router is involved. And that's where NAT traversal can kind of come in, because we need to, what is the point of NAT again? We are going to assign or translate private and public IPs. So the reason this can be a little bit confusing is because there's a lot of different IPs that are going on in this. I have my home network IP, and then that goes away, and I get assigned a VPN IP from their network. But now we're talking about network address translation because I need a public IP. So how does this all fit together? When I am reaching out to something outside of this environment now, anywhere else, it could be reaching out to google.com, network address translation needs to take place inside of the VPN connection. That's where this term encapsulation happens. So my packet is going to go from this workstation. Technically, it does go through my home router, which pretend it exists down here, and it's going to go through here. This is the endpoint where my packets are actually leaving, is the VPN endpoint or the external endpoint here. Then this packet goes through the VPN tunnel and out to the internet. So at this device, this layer that gets put on is network address translation. So the original packet stays the same. This would be the same packet. It looks identical here before the VPN. I send the packet, goes through the VPN, and it hits the NAT device. But it's the NAT device in their network. That's kind of the important piece here. So this is where transversal comes into play, because this device has to be capable of transversal, of that traversal capability, because it has to know if a VPN is being used. We have another internal endpoint. They're not using a VPN. If they send out a packet, it just goes through the typical NAT process. There's nothing different about it. But in here, because we're using a VPN and there's other layers of networking that's going on, they choose to encapsulate the entire thing. Now, I'm not going to go into detail on this, frankly, because I don't really fully understand why, but that NAT traversal, it gets encapsulated in UDP packets instead of TCP. My only understanding of why that is for efficiency, just because we are doing a lot of network translation at this point, and different routes are coming into play, that UDP is a little bit faster because it's not connection oriented where we're requiring that back and forth. So it gets encapsulated and it goes out. Then the return traffic comes back and it's just going to get decapsulated. So those other layers are going to get pulled out. So the network, in a sense, network address translation is doing its reverse job. And then this will get passed up back to me. And it'll go back and forth like that. So at this stage where it's getting translated between public and private, instead of just network address translation happening, the traversal adds encapsulation on it. So again, key point is that not all devices are capable of this. They have to be VPN aware. Devices have to be VPN aware for traversal to come into place. So let's link this as our final talking point. Let's talk about why static IPs are so important in relation to the traversal piece. We're going to take the internal server part of it. So the use case we had here was I have a dynamic IP address that's assigned, and it's assigned to me by the DHCP device, whatever's doing that. For an internal server, it's pretty common to want to use a static IP address in this case. So this is actually can be a static route between the router or the firewall to that internal server. So it makes communication simplifies communication because there's fewer steps and there's lower latency that needs to happen. There's less decision making and encapsulating what's going on. This also makes it a little bit easier because it doesn't have to be the tunnel configuration for this VPN can include the encapsulation almost, because it knows what the endpoint it's going to is. I'm not phrasing that very well, so there's going to be some confusion, and I apologize that we'll have to end on a little bit of confusion, but the points of having a private IP address when it comes to NAT traversal and VPNs is it really simplifies your configuration because you can have static routes in there. So you don't have to have those dynamic tables that are in here doing a lot of work. Okay. Boy, thank you guys for your patience. We went through quite a lot here in this session, and we definitely took some sidetracks onto some topics that weren't planned. And that's exactly how I like it. I like when we have a plan and we can follow that, but I would much rather we talk about the sort of things that you guys want to talk about in study groups. So we're going to wrap things up there. I'll be on for a couple minutes if you guys have questions or things you want to chat about. But in general, I just want to thank you guys for being here tonight. Thank you for your patience with me and your support as I'm learning to teach and do better at this. And good job studying. Keep it up. Bring your problems to the group. Bring practice questions, challenges. And yeah, that's really all I have. And we can kind of conclude and wrap up there. Thank you, Fred. Yeah, it was great meeting you. I'm glad you were here. I hope to see you. I won't be here on Thursday, but next week I hope to see you.
Hey, Josh, how would I reach out to you about this traversal?
Yeah,
Lost
great.
me. There were just points of your explanation. It seemed to skip something, and I was following, and then it kind of got fuzzy.
Yeah, thank you for being honest, because if I'm explaining it somewhere, it might not be clear. And sometimes you need to hear a couple of different perspectives or a couple of different types of explanations for it to really click. So thanks for not shying away from that, John. The best way to get in contact with me is through the school platform. If you look for Josh Botts, you should find me. I post pretty regularly. So you can send me a direct message if you want, or just make a post and you can tag me in that post. If you just do @ and Josh Botts should show up for you. But yeah, please, that's open to all of you. You can reach out to me. My time can be limited, but I read anything that I get and I document it so it's in my plan of attack for these study sessions. So I love it when you guys reach out.
Are we picking up on authentication for Thursday?
Yeah, well, I don't know about this Thursday. So Sarah, who is on the call, is one of our moderators for the group, and she's going to be covering for me on Thursday as I'll be out. So my understanding is she'll be focusing on some cryptography and cryptographic attacks. I don't want to speak for her, but my understanding is that's what she'll be discussing on Thursday. And then when I return next Tuesday, a week from today, then yeah, we'll pick it up at authentication mechanisms and might fill in some things that Sarah doesn't have time to cover if that's the case.
Sounds good. Thank you.
Yeah, absolutely. I'm so glad you were here tonight. Thank you.
All right, everyone. Bye.
Awesome. Well, looking forward to chatting with y'all in the community. Reach out if you have any questions. Keep studying hard, and I'm looking forward to seeing you next week. Reminder, next week is the new schedule that'll be launching. So I don't have the times in front of me, but it's still a Tuesday evening at US hours. I think India, that's early on Wednesday morning. And then there's a Thursday morning session as well. So the Thursday is going to now be morning, at least for the US people. So awesome, guys. I hope you have a wonderful evening. Good luck studying, and I will see you next week.
Thank you.
Thanks.
Bye-bye.
Good night.
Good night. Thank you.